Hi guys, welcome to my channel. So today let's solve a table Leet question. The description of the question is as follows: that we were given a start cell, row start and column start of rows and columns grid facing east. The northwest corner is the first row and the first column, so northwest corner here would be this, and the southeast corner would be the last row and the last column. Eventually, we'll reach all rows and columns. Okay, we need to walk in spiral shape to visit every position in the grid. Eventually, we'll walk and continue outside of the grid. If that's the case, then we'll just proceed and we need to visit all the cells within the matrix. We need to reach all rows and column spaces and we need to return the order of coordinates that we visited. Okay, great. So let's just consider this example. Visually, it's too simple to just check it out because first we started at this position and every time this is a east facing grid, so we need to move towards the east. And while moving towards the east, first we'll visit this cell, followed by this cell, and then there's a boundary over here, so we'll need to move towards the south. And we visited 3, we visited 4, and followed by 5, and now 5. We couldn't move here because we need to visit 6 because 1 is visited, so now we need to make it spiral, right? So we need to move towards 6. If we move towards 15 and later we can to 6, then now it won't be anyhow spiral. So we'll go to 7, sorry, 6, 7, followed by 8, 9, and now we'll just come out of it because we just need to make it spiral, right? So to make it spiral, we couldn't go this way, so we'll just walk outside of the grid and then we'll move here. So it's fairly simple because it's looking as a spiral. So for making this understand, let's just analyze what we done. So in this example, for the first case, what we did, move or we'll just move one step in each direction, right? So we moved one step in each direction, and once we are here, again what we are doing, move one step in west direction. Sorry, in south direction. So once we are here, we just moved one step in south direction to get our spiral condition satisfied. And once we are at one step in the south direction, then we moved two steps in west direction, right? Because this is the one step, this is second step. And once we are here, to reach over here, we move two steps in north direction. So now once we are here, now what we'll do, we'll just move three steps because one, two, and we couldn't move two because that won't make a spiral. We'll need to move three so that we'll enter outside the grid. So we'll just move three steps in each direction again. Again we were here. Now we'll move three steps towards south. One, two, three. So we will be ending up here. So got the intuition and it repeats on the similar way. So the idea here is we are moving as a pace of directions with equal step size. In other way, east and south at the current iteration would be having same step size, and then in the next iteration the step size would be increased by 1, and then west and north will be having same step size that got incremented by 1. So this is it. First, let me take some. I'll call it vector ends. Let's start coding for it. I'll call it drs array, and what my drs will be containing is drs. I'll call it distance will be taking in both x and y direction. So it's a combination of dx and dy. And we already have seen that we'll first move in the east direction. For moving in the east direction, the x coordinate should remain same and y coordinate should increase by 1. Right here, if you consider this example, we are in the same row and we are moving towards a high column. So it's a 0, 1. And for south direction, we would remain in the same column and our row would be increased by 1, because here we are in the second row, we are in the third row, but our column will remain the same. So for this, dx would be 1 followed by dy would be 0. And next we will move towards the west direction. Towards the west direction, our row would be same and we are decrementing our column by 1, so it would be minus 1. So dx would be 0, dy would be minus 1. In the same way, if we'll just negate this, so minus 1 is 0. In the other sense, like after moving towards west direction, we need to move towards the north direction. And in the north direction, you could see our row remains decrementing by 1 and our columns remains the same. So change in columns is 0, change in columns would be minus 1. Sorry, change in rows would be minus 1. We already have this, and initially our step size is what? 1. So I'll just call step size will be 1 initially. Now I'll also take a traverse vector to just check all the traverse pairs hit, and initially my direction would be what? 0, because initially I need to traverse towards the east and east is having coordinates 0. I added them in order for purpose so that after this our direction will be incremented by 1, so we'll be moving towards the south. Now having this done, we just need to check break the condition if my traverse dot size is. I need to continue this loop until I traversed all the rows. In the other sense, all the elements of the grid. In the other sense, until my traverse size is less than rows and columns, I'll just need to keep on iterating. And I told you we are moving in pairs of direction. So pair will always have two numbers, right? So I'll just call it less than or equal to 1, I plus plus. So here we are having two pairs, I mean two directions, 0 and we are moving till 1. And in the current iteration, I'm just checking, I'm just iterating till all the steps, because in the pairs we need to move the step size. We need to iterate through all the step size in the given iteration as we have seen here. So in the first step, uh, where our pairs are east and south, how many steps are we moving? One step, right? So it should be less than step. We will continue this process. And for the first pair, it would be east and south. So I'll just check if my current row start is greater than or equal to 0 and row start would be less than rows and call start would be greater than or equal to 0 and call start would be less than columns. If this is the case, then I'll just uh, push back row start and call start. So once we done this, we'll be moving towards the east, right? So for moving towards the east, our we'll just add what's our array name, dr of, and our current direction is dir. So what I'm doing here is I'll explain you. So we are moving towards the east direction. In the east direction, if our current row, for example, here is 1 and a column here would be 4, right? So to move towards east direction in the next iteration, we need to increment the row size by the effective size that will be getting us when we are moving towards the east. So when we are moving towards the east, the effective row change would be 0. So here row start would remain same and effective column start would change by 1. So if I made this dir 1, 0th index represents the change in direction of x, which is dx, and 1 represents the change in direction of y, so dy. So our row start and column start are changed here. And now, once we are out of this loop, I'll just tell you that after one pair is completed, that's east and south are traversed together, I'll just need to increase my step size. And here also, we iterated through all the steps for a given direction, and we'll move to the next direction coordinate in the page. So we'll just increment dir by dir plus 1% for y percent for, because dir will always lie between 0 to 3, 0 representing east, 1 representing south, 2 representing west, 3 representing north. So I'll just return the traverse to array. Let's call it rows and columns. Step is not defined, so that's defined as step size. Sorry for that. Here also is similar. This is R start and R call, not with start and C start. Again, this also should be changed to R start and C start. Ah, I'm sorry, this also needs to be changed. Yes, so let me just submit this out. So to reduce the time that's taken, you could simply specify the compiler that no need to import the libraries from C that are required for taking in input and taking giving out output. Because I'm not performing those operations, I'm just returning my answer. So you could see now the time taken would be fairly reduced, because libraries that are needed for taking input and output, which are not necessarily required for this code, will be ignored. So this is for today. Let me explain you again to give more clarity. So this dr represents a change in direction of x and y, having moving in a current direction. So if we are moving in the east direction, then there won't be any change in the row, and column would be increased by one. So similarly for south, west, north, and currently we have checked here our step size is one. So we are initializing our step size with one, and we are having a traversed array to find all the points or all the coordinates that are traversed at. And now we just need to traverse the grid until we traversed all the positions. So while our traverse size is less than rows and columns, in the sense that it's a zero based index array, so 0 to rows and columns minus 1, every path should be, or every coordinate should be visited. Until then we'll perform this while loop, and in the current iteration we'll just move in a pairwise directions like east and south. So we just had this for loop to move in a pairwise direction, and for every pair currently we'll move step size towards that direction. So step size here would be step size, and in the current direction we'll be moving. So initially our direction is 0, so currently we'll be moving in the east direction, and after having this done, we'll just need to change our direction. That's according to the page. So that would be again direction plus 1% for. So first we completed our south direction as well, then we'll be out of this loop as well, and again we'll be coming, and then our direction would be towards west. So we are moving pairwise, and for every pair we are incrementing our step size. So that's it for today. Mm. Feel free to add anything in the comment section if you feel anything is unclear. Thank you.